So I have a bit of a treat for you this time around. Since we're about halfway through our ASM MOOC, and we've learned that aerospace design is all about difficult decisions and compromises, I think it's time to put some of this knowledge to the test. I've been thinking about how to design a panel that will be fitted in the upper part of a wing. In my preliminary research, I determined that there are 3 key requirements for my panel. 1, it must be able to withstand compression. You'll learn about this in more detail next week, but because of lift forces on a wing, it tends to bend upwards in flight, so the upper skin must be able to take compressive loads. 2, it needs to be able to hold its shape as a sheet. We want it to be able to handle loads, but also not deform significantly under them. If it does, it could affect the aerodynamic profile of the wing, among other things. And 3, it should be lightweight. Weight is critical in aerospace design, so the lighter the better while still being safe. Now I could go down to the Delft Aerospace Structures and Materials lab and create some design ideas from metal, but that's very time-consuming and expensive. I'll do that eventually, but to get a rough idea of what works and what doesn't, I'll use something that's easy to use and acquire: cardboard. I ordered some new lab equipment the other day, so I have a lot of this stuff lying around. We'll also need something to test resistance to compression. A notepad will do perfectly. This way, we know we're always loading the cardboard with the same weight and we can compare the results. To start off, let's see what happens when we take a thin piece of cardstock and try to load it. Bit difficult, isn't it? It doesn't look like it can withstand the compression load, and even under a lighter load, it seems like it would bend out of shape quite easily. So unfortunately, our cardstock doesn't meet our first 2 design requirements. It is, however, a lightweight solution, but that doesn't outweigh the other 2. What if we try a slightly thicker piece of cardboard? Maybe that would have a different effect. Here we have the back cover of a spiral-bound notebook. Once we actually manage to balance the notepad, it looks like we do have a structure that supports the weight and doesn't bend out of shape. However, it is substantially heavier than our previous test, so we'll keep it in mind, but I'm convinced there's a better solution. Since changing the thickness isn't getting us anywhere, let's play around with geometry a bit. Remember my affinity for origami? Maybe some folding could be useful here. We can simulate a thicker plate with thin sheets by creating zigzag folds in the paper. The notepad is much easier to balance now. Seems like a good design, right? But if we think about it a bit more, it does withstand compression and is lightweight, but it violates our second design condition since it does not look like a smooth sheet anymore. It's not particularly aerodynamic, and it's also quite heavy compared to the flat sheet. The same area requires much more material to have the same effect. We're certainly on the right track, so let's look at one more option: stiffeners. Instead of having a continuous folded sheet, let's place folded sections selectively along the length of a flat piece of cardstock. I'll choose a hat shape for my stiffener, make 2 of them, and glue them to the cardstock. Now let's evaluate our design. It meets the first requirement, that it withstands compression. It also meets the second requirement, because it does hold its shape, and if the stiffeners are placed on the inside of the structure, the outer surface remains smooth. And finally, it is a lightweight solution. There are only enough stiffeners to take the load. It is certainly lighter than both the thicker cardboard and zigzag folded options. These stiffened panels are precisely what is used in aerospace structures. A thin wing or fuselage skin is too weak on its own, but the inclusion of stiffeners strengthens it and allows it to handle the compression loading. You'll learn more about these structures in the next lecture. And if you want to, you can try out some designs of your own. Can you come up with something better? Maybe a different stiffener shape. Give it a shot and discuss your ideas in the discussion forum.